Okay, in this presentation we're going to talk about metadata. For pretty much the entire course, it seems like each week we somehow run into the topic of metadata. You've heard me bring it up and I'll say something about it and then say, well, we'll talk about it later in the course. And now it's time to talk about metadata. Metadata, enough can't be said about it. Its importance, especially for digital libraries. I would hazard to say that perhaps we could spend a whole course on it, and you may still be learning more after that. It's very important. Probably one of the most important things to learn in digital libraries. It's the thing that I find when I'm doing digital projects, archives, library type stuff, data. It seems like metadata is the thing that is the most time intensive and requires the most brain work and planning and logistics and so on and so forth. There is a lot of expertise that goes with understanding file formats, definitely, but metadata is the thing that is really important. And so let's talk about what is metadata. Well, first let's think about what a digital object is. Pretty much up until now what we've been talking about is really one part of a digital object, or how I define a digital object, and that is the digital asset itself, or the file bit stream rather. So when we think of an image, sound, a PDF book, or any kind of document file, audio, data set, etc. When I think of the asset, I'm thinking just the bit stream. So this is a thing that you could see an image and know nothing about it. You just see the image, sound, and so forth. Whereas to complete what I consider the whole package, the digital object, we have what would be called its metadata, or affiliated metadata, and that's the data about data. So you need both. You need to have the bit stream, the thing that we care about, but in order to understand that bit stream, image, sound, book, audio, you need metadata to describe it and make it understandable. So why does metadata matter? The late, great Roger Ebert defines it as this: doing research on the web is like using a library assembled piecemeal by pack rats and vandalized nightly. So without metadata on the web, the internet would be pretty tough to manage and surf through, and that's just the internet, what he's talking about, which is a big thing, the World Wide Web, but as you know, we use a lot of things that are not on the web. So how do you find these things: audio, images, video, and text? Well, one of the things we do to make them discoverable is to use metadata. So what metadata does is it supports discovery, navigation, presentation, access control, administration and management, and preservation. Each one of these, discovery, so when we think about searching the web, doing Boolean searches, indexing the web, that's all done using metadata. Navigation, once you found the resource that you want to look at, whether it be a website or a book or so forth, you still need metadata to navigate through those resources. How they're presented, metadata can dictate that. Access control, again, I've gone through all these, but I just wanted to define some of them. Access control would be like rights. Do you have the privileges to see that object? Can you check it out? If it's a digital library, can you get it on your reader? There's all sorts of access controls that you might have, and metadata would be where you would it would be in the metadata where you would make those distinctions and those restrictions. Preservation, access control, administration, management all kind of go together. Preservation, there's a whole set of metadata standards that support preservation. There's technical things that metadata can support. So what is metadata? So in a way, it's really a fancy word for cataloging. I think I first heard of metadata maybe in the probably around 2000, late 90s. And if you could use that word, you sounded like a really smart person. But now we kind of hear it everywhere, and basically, I think it's just sort of a fancy word for cataloging. Um, in the standard library world, catalog records are metadata. Basically, they contain the information about the book. Here, I've got an old card catalog, card from a card catalog describing what the book The Stranger is about, and there's all sorts of information. Usually, the who, what, where, and when. Those are the things we think about, like conventional card cataloging, capturing subject headings, author headings, those sort of things. So once again, we'll just keep attacking what is metadata. Metadata is the data that facilitates management, description, and preservation of our digital objects and collections of digital objects. Metadata creation is typically governed by a body of standards, best practices, schema that when used correctly ensure effective management, description, and preservation of digital objects. So metadata really is in some ways the backbone of a digital library. And we have one more definition. Metadata is structured information that describes, explains, locates, or otherwise makes it easier to retrieve, use, or manage an information resource. Again, an information resource, I would kind of say a digital object and that are interchangeable. So we have types of metadata. I kind of alluded to some of them, things we do with metadata, but here are ones that you'll see versions of these types throughout the literature. Descriptive probably being the one that you will sort of do first or learn how to do first. As our final project, you'll learn how to do descriptive metadata, and basically that's the one that facilitates resource discovery and identification. That's sort of the who, what, where, and when, and why of a digital object. Or in the analog world, if you're describing a photo, a print photograph, or you have a book like Camus' The Stranger, that's where you're going to do a lot of this kind of conventional stuff. Administrative, we do that in the print library world, and we do it in the digital library world as well. So this would be supporting the resource management. So you might have things like administrative might be who owns it, sort of what rights you have to use it, copyright, that sort of thing. Structural. Technical and structural sort of related. Structural would be what holds all those components together. For example, I talked about when we did our unit on text and documents, a lot of times you have a multi-page document, i.e. a book, and you have to know how that book fits together structurally. So that's where structural metadata comes in. It might say what's page 1, page 2, page 3, that sort of thing. That's just kind of structural metadata simplified, but that's what that does. Technical metadata, there's all kinds of technical metadata, but when you have technical metadata, sometimes it could be in the embedded file of like an image, for example, or it might be separate from that file in the digital library system, and this might, for example, tell how to render an image, how to render a video. It might tell when you click on that image and it retrieves the metadata, what piece of software to get to render that. There's all sorts of other technical metadata, things about character sets to use, all sorts of stuff. Use, this again would be a kind of administrative like, but again, what level of or type of use is allowed, and this would go in the metadata. And preservation, again, we talk a little bit about preservation in this course, but preservation, a lot of the work that's done in preserving digital objects so they last 10 years, 100 years, last through technical obsolescence, a lot of that is done in metadata, and that information is stored with the object. Sometimes it might be in an entire collection of objects, but preservation metadata is used quite a bit, and we're getting, as a community, starting to use it more and more, and obviously realizing its importance. We've already seen this slide before, an image. This file naming, to me, is what I think of the first thing you do when you start caring about metadata and implementing it. Well, you need to have good file naming practices. So that in and of itself is sort of a poor woman's version of metadata, because it's so easy to do. It's just write in the file name. Metadata storage, this would be what is the technology that we use to store our metadata in. Now, metadata can take the form of many different forms. In a few slides later, we're going to talk about XML, and that's the one that me professionally, I tend to, if I'm going to talk about metadata, you have to know something about XML. Not a lot, but you need to know something about it. But it can also be stored in databases. Databases are used all the time to store metadata data. It can be stored in a database. It can be stored in an embedded in the file, as we've already learned. So there's metadata in there. So like it might say camera, that's a metadata tag, and then it's set to a value. What kind of camera was used? Oh, it was a Canon, DSLR, or it was a Nikon, just for example. It can be in a flat text file. So a flat text file is typically a file that's all ASCII text. That means just text that's from your keyboard that has not been formatted. It's not like a Word document. It's not a PowerPoint presentation, for example. It's a flat file where all the formatting's been stripped out of it, and that's what a flat text file is. An XML file, again, is a sort of a flat file, but it has marked up data in it using XML as its markup language. And XML, almost every single metadata standard, which we're going to talk about in another slide or two, is expressed in XML. XML is sort of the language du jour, I guess, or the technology du jour of expressing metadata standards, but not the only one. It's really was pretty popular up until, I'd say, it's still very popular, but its popularity is waning just a little bit, because now what we're finding is people are storing, a lot of organizations that develop standards and systems and so forth will store the metadata in a database, but then express it using XML. And that's something, if you take the XML course or do some self-study on your own, you'll learn more about. It's really beyond the scope of this class, but XML anyways and metadata kind of are a very happy marriage in general. XML databases, those are different from XML files. XML files are, in a sense, just a flat text file, but they are using the markup language XML in that flat file. XML database is a database that uses XML technology. It's different than a relational database or like MySQL, which I kind of think is a conventional relational database, or Access for that matter. An XML database is kind of a recent invention. Databases, as we know them, have been around really since the 50s and 60s. An XML database is a rather new thing. It's really only come about since the 2000s. JSON is another type of text format container that you can put metadata into as well. And then there's linked data, which unfortunately in the course I don't talk about too much, because it really is important, and each day that goes by it keeps getting talked about more and more. Is really, this is the future of the web, future of digital libraries, the future of libraries, ILS systems, the next generation, like BibFrame and so forth. And if there are any catalogers in the class or academic librarians, you've probably heard about BibFrame. But anyways, this all will be using linked data, and this is sort of the future, not only of the World Wide Web, but the future of digital libraries. Again, unfortunately, we don't talk too much about it. Probably next week or the following week I'll get into it a little bit more, but our final project, we don't really deal with linked data too much. So anyways, but something to keep an eye out for. Metadata standards, okay, so I just mentioned standards. So we have metadata. Anyone can create metadata. If you know how to use a little bit of XML or just know how to use a word processing for that matter, you can come up with a standard. But metadata, you could come up with metadata, your own metadata set, if you will. A standard, though, although you could have a standard that, say, you and one other person uses, I don't really think of that as standard. I think of a standard as emerging from a community. And so the community could be any kind of community. We're the library community, there's the archival community, there's the farming community, there's the sports community, there's the medical community. Any profession has its own community, and every community has a specific information need. And anytime you're dealing with information needs, especially once you get into the world of the web and in our case digital libraries, you need to have a set standard for how you encode your information, and that's where metadata standards came into use and why they become important. One of the things that metadata standards try to do is they try to build in interoperability. Basically, it requires not only that standard, that metadata standard, be able to talk to itself, but it also be able to talk to other metadata standards from other communities. So here's a nice quote from Howard Besser. He actually came here last year to speak. He did an audio digital digitization workshop that was excellent. It was last spring, actually. Okay, and moving from dispersed digital collections to interoperable digital collections, the most important activity we need to focus on is standards. Most important is the wide variety of metadata standards, including descriptive metadata, administrative metadata, structural metadata, terms and conditions metadata. So there's lots of types of metadata. There's not only metadata, as we talked about, within one community, and we're going to talk more about this. So we could have Dublin Core, we could have METs, we could have mods, we could have MARC. Those are all within really one community. We just call it the library community. But each one of those standards have to be interoperable, and they need to be able to speak to each other. So here I just mentioned a few of them. We have element sets. That's just kind of another, or tag sets. Again, typically we think of those as standards. The standard, if I can just back up again, not only is it a community, but you think of a standard as being voted on or being somewhat democratic how it's decided. So when you're developing a standard, you're going to have a lot of input from the community that you're creating the standard for. So if it's the library community, typically you're going to have major players or stakeholders involved. So like if it's a library standard, a lot of times the Library of Congress would be involved, potentially OCLC. We've already talked about them a little bit. You want to have the small guy involved, so you might have public libraries involved. Again, you might have some other big players like Harvard, Yale, New York Public Library, so on and so forth. But you're going to have big stakeholders involved, and they're the ones who are going to develop these standards. So one that was developed a long time ago, and we're going to, in another slide or two, talk more about it, but was MARC, or MARC 21. That's a standard that's been with us since the 60s. Dublin Core, kind of a more simplified, sort of quick and dirty standard that was developed to sort of handle a lot of World Wide Web resources that librarians want to catalog. EAD, this is one that's closer to my sort of subfield of libraries, archives, and that's encoded archival description. Again, a community standard for the archival community. Mods, basically a metadata standard that was XML friendly and really designed to replace Dublin Core. VRA Core, this would be by the visual art historians and the visual resources librarian community. Getty is the one that really helped develop that. They were a major kind of the library. They were like the Library of Congress of visual resources, if you will. So they were a big stakeholder that developed that. METs is another metadata standard that sort of cuts across many standards. It's sort of a wrapper standard. It never really sits on its own. It usually is used in tandem with other standards. So let's talk about Dublin Core, and this is what, for your final project, I haven't totally set it in stone yet, but most likely you're going to be using Dublin Core. Dublin Core is something we've used in this department and many libraries and archives have used because it's so easy to use, relatively speaking. It's a really basic standard that sets out 15 fields or elements to use in resource description. Dublin is due to its origin. In 1995, OCLC is based in Dublin, Ohio, so I think they just thought, let's call it Dublin Core, the core being a core set of tags to use. OCLC is based there, as I just mentioned, and it oversees the standard along with many other standards. It's become kind of, and I guess I mean this in a nice way, but the Google of the library world. They really are a mover and a shaker for libraries and archives. So how did and why the Dublin Core came about in 1995? Well, this is a little bit of a history of it. With the advent of the web, there was a huge increase of document-like resources on the web. Indexing at the time, we did not have Google yet. Google really didn't come into full swing until the early 2000s. So indexing the web was a very tricky thing. We had many search engines, like Yahoo and Alta Vista and Excite. What else was there? Metacrawler. There are all these ones that have more or less gone away because Google has more or less won the battle of search. So one of the things to help discoverability for these search engines was Dublin Core. And the belief was that, descriptive metadata would improve discovery, and it did help. And it also, the idea was to basically make the description the skills needed to do that description low enough that almost anyone could do it. I mean, you needed some training in it, and you will receive that, but you didn't need to be a professional, like library cataloger, to describe a resource on the web. Anyone could basically teach themselves, or a workshop they could learn. And basically what the idea was to sort of create a card catalog, I guess, of the web. And it's, I guess, worked to one degree or another. I think there were a lot of shortcomings to it. And basically, here's the set, 15 of them, and it's what I call the who, what, where, when, and why. It's sort of just a quick and easy way to sort of say what Dublin Core does and what any descriptive standard should do, at least. And each one of these, each one of these are extensible. So when we say, and I don't think I've defined that term in here, I probably will next week, but extensibility in a metadata standard means that it's extensible, means that the user of that metadata tag standard can alter the tags, and they can basically customize them to their own local need. So sometimes it means they're repeatable. So like we have a creator, we could use this tag set and say, oh, we're going to use the creator tag, but we're going to change it to what we want to call it, which is author. We don't want to call it creator. Or we can have multiple creators or authors, so we could have creator 1, creator 2, creator 3, creator, or co-creator, co-creator. It means the field's repeatable, and it just gives the user of that metadata standard some flexibility in how they implement it locally. Back to interoperability. This is the ability of a system or a product to work with other systems or products without special effort on the part of the user. And I'll just read again here, it's a Paul Miller quote, "To be interoperable, one should actively be engaged in the ongoing process of ensuring that the systems, procedures, and culture of an organization are managed in such a way as to maximize opportunities for exchange and reuse of information, whether it's internal or external." And metadata standards are what allow that interoperability. So we've heard the term silo used a lot, and silos more or less, I guess, are a bad thing, but sometimes they're necessary. There are reasons why silos emerge. But the idea with being interoperable is that you want to get rid of duplicate metadata. If you've got a metadata record for one object and that object lives in multiple systems, you only need to have one record. You don't need to have a bunch of different records, duplicate records. When you have silos, you get reduced efficiency. And then you also get greater chance of inconsistent description. There's a lot more reasons why silos are bad. I've just listed a few, but they do emerge for certain reasons. Organizations become siloed because it even though overall the efficiency might be reduced, there is some efficiency to be gained when you work in small groups, and that's how these silos come about. And each group, department, say you're in a university library, they have their own culture, each unit. The units, it can become difficult for them to talk to each other, not even face-to-face, but to have their systems talk to each other. So metadata, one of the ways to break down those silos is to make it so they're interoperable. And you want to do that right at the beginning. You don't want to develop a metadata tag set and not speak to other stakeholders that are sort of what you would call like sort of friends of the library, or within your own library, friends of your unit. So any other community that you're going to have to interact with, you want to make sure whatever metadata set they're using or standard, that it talks to your standard. And so here's some examples of some silos. These are not all silos that don't necessarily, some of these silos can talk to other silos. They can be interoperable, but these are ones that have become siloed in the past, maybe not necessarily today. So for one example would be the ILS or the OPAC in a public library or academic library. Institutional repository, it works great and fine on its own, but say you want to have those records be able to show up, stuff that you, objects that you have stored in one institutional repository, you want it to show up in a sister institution's repository. How do you make those speak to each other? Various vendors, sometimes they use standards that are proprietary, they don't want to share them. A digital asset management system, not unlike an institutional repository, sometimes you can develop metadata standards that you're using that are just localized to that that installation of that system. So if you're not using a community-wide accepted standard, and you go to export out of this system into another one, that can be very difficult, those migrations. Or you want to open up your system, say using an API, for example. If you're not using a standardized set of metadata tags, that can be very difficult. Learning management system, we use Blackboard and Sakai, again, using open standardized metadata tag sets are very important with that. And same way with the CMS. Again, this is kind of getting out of the digital library world, but just to show you that metadata really is used in all walks of life now in the sort of information world. One of the first metadata standards that we ever used as a community that predates, I think, most of us in this class, it predates me, is the rise of MARC, machine-readable cataloging. It was almost single-handedly developed by this woman, Henriette Avram, late Henriette Avram. She was a remarkable woman who really took probably the biggest jump in library innovation was done by her when the advent of MARC, and then subsequently when ILSs came in to develop, when they could really realize the full potential of MARC, to use it, in online catalogs. That's really the biggest jump in libraries in the 19th century, the 20th century. But basically what MARC did was it allowed you to mark up records in a standardized sort of way. So card catalogs became standardized. The catalog records, the individual cards themselves, and how the books were described and so forth. That all became very standardized with the rise of MARC. And it wasn't until the advent of SGML and then later XML, as I was just talking about, when that distinction between markup and the information was really made clear. Here's a MARC file. Again, this is a metadata record, but the markup, the distinction between what is markup and information is not clear, as you can see in this. You really need a computer to read all this basically unreadable code. Only a computer would need to read this to know what is the title, what is the description, what is the date, what is the library, the LC number, the call number, subject headings, and so forth. So we've had metadata standards for a long time, but they started out actually very cryptic and hard to read. Dublin Core later on was kind of a quick fix for coming up with something to sort of run side by side the MARC standard, but really what was developed to sort of replace MARC was MODS, which was an XML based standard. It was sort of a derivative of MARC, but it will definitely supplant Dublin Core. But MODS, we use it a lot, but MARC has not gone away yet. MARC is still with us. And anyways, I'm not going to talk too much about MARC because I'm not a cataloger, but basically I just wanted to show you some history there. XML and metadata, we're not going to get into XML too much, but I just wanted to show you what a tag looks like. XML allowed us to separate markup from the information, so you have markup tags, and then you have the information that those tags surround. So what is XML? It's extensible markup language. XML is a set of rules for defining markup languages and describing data. So XML means that once you learn the technology of XML, it allows you to design your own markup languages or markup standards and metadata sets. It allows you to do structured data that web applications can understand, and there's a way to validate how the XML markup is created, that if you have certain tags that need to appear in a certain order, XML has a way through validation technology to validate, do you have the correct title, are you using the correct metadata tag for author, are you using date, do you spell it the right way, and so forth. So XML technology is a way that basically enabled metadata standards to sort of come into their own. So again, here's an example of MARC versus XML. MARC really sort of puts the onus on the expert or the technology to know what is the information versus the tag. It's not very explicit what's the tag and what's the information that tag is marking up. Versus XML, you can see here's the information and this is the title. So it tells us the data about the data, that this title is the big heat, and the name, we wouldn't have value in there. We would have something like Mark Wolf or maybe the creator of the big heat. So again, as I mentioned before, XML has become the de facto encoding technology standard for representing metadata descriptions, but you can do it many different ways. You can use databases, flat files, spreadsheets, as I said before. Here's a sort of another pictorial representation of like a digital object needing metadata. We talked about, you know, bound book, but in the digital world, you may have many digital files to represent that bound book, or, you know, a digital book. So you're going to need metadata to ensure that all those files get rendered in the correct way and that they don't get mixed up on the web. METs is another one I talk a little bit about in this course, and if you take the XML course, we do a little bit. But basically, METS is a way, it's a wrapper metadata standard that allows you to have many different standards involved. So you may have a digital library that uses, you know, a little bit of EAD in there. It may use mods. It may use Dublin Core, and it may have like another metadata standard from another community, say, you know, the botany community or ornithology or biology or whatever, where you need to use something that's very specific to that field in order to render it and make it usable to your users. METS is a way to do that. You can wrap all those standards up in that, but it does a lot more. It handles a lot of technical metadata very easily. Anyways, it's sort of a metadata standard, if you will. Again, here's how METS might be working. You might have do the structure. So again, a book might handle the description, administration, and these could all be different standards being used to represent it. Some of them could be METS doing it, or it could be another standard. There's TEI, with Text Encoding Initiative, that it could be using for doing books, or it may not. It may TEI is a very specific, kind of hard to implement standard, so it might be something a little more basic like Dublin Core. Again, we talked about this as a little bit redundant here, but where metadata is stored. Again, embedded metadata. It could be in a spreadsheet, database, flat file, XML. Here's some tools. This would be, again, for not so much you're storing it, but how do you actually enter the metadata? Because you could enter it in a spreadsheet and keep it in there, or you could actually turn it into a CSV file, which is essentially a text file. You could use that doing Excel. A database, you could create like a standalone Access database where you have like forms where you can enter the data in there. With each field, say you have a creator field, well, in Access you could create an actual field with a little form, a window to type in the data for that. It could be a web form. You could have a MySQL PHP type web application where you enter the metadata that way. It could be right into XML, doing angled brackets and tags and doing it that way. Or it could be in some kind of content management system. You could be using Content DM, where you could basically create the metadata right there and enter it. There's all sorts of different ways. There's other metadata management tools. We're going to look at OpenRefine a little bit, but there's many different tools that we use. Some people, OpenRefine was formerly used by Google. They've since sort of let it go out into the community. I think, again, with the Google Books project, that was something they used quite a bit of, in the same way that Tesseract, that they developed that and sort of kind of turned that out into the community for free. Here's another one I listed. This isn't that big, but it's something you can look up, called OpenWMS, which is basically a metadata management system, and it's another way to create metadata for your digital library and have it be kind of like a standalone system, and then you can export your metadata into a digital library or whatever system you're using. But there's a lot of different tools we use here. We sometimes use programming languages. I don't do too much of that, but I have colleagues here that use things like Python. Perl is used. These are all just like general programming languages that are good with text. We sometimes just do find and replace. There's all sorts of things that you might use to manage your metadata with. And OpenRefine, when we look at that a little bit, you're going to really see that those are pretty powerful. Just like Renamer, when we were doing file naming, you want to have tools for automation for doing metadata, because again, metadata, you're looking at hundreds, thousands of records that you're sometimes dealing with, so doing them all by hand is not really feasible. So you need anything you can do to kind of give you a little bit of a boost or help in managing your metadata. You want to find out about that tool and learn how to use it. There's rules for description, so you may have a metadata standard, but what do you actually put in those metadata tags? There's another standard for that. So we have vocabularies for what subject headings you're allowed to use, like authorities, name authorities, subject authorities, geographic place authorities. There's genre authorities, so the art and architectural thesaurus does that. So what kind of what's the form factor for what the content you're using? Is it a memo? Is it a diary? Is it a photograph, video, speech? These are things that genre does. There's all sorts of rules for description. For the archival community, we have RAD, which is the Rules of Archival Description. And then we have DEX, which is Describing Archives Content Standard. So that's it for now. We're going to keep talking about metadata. The two readings, I urge you to dive into those as soon as possible. For Miller, those are a nice, really in-depth, but I think clear and succinct sort of introduction to metadata. So those will definitely get you going on the right track.